Hi, this video is designed to show folks who have a sodium hydroxide injection system or thinking about getting one, one way to kind of refill the slurry tank. This system I have in place here, I started with a calcium tank and some really acidic water in the region of 5 pH. And the calcium tank, even doping it with a bunch of mag oxide, was not adequate to bring it up to a pH of anywhere near 7, and I ended up corroding my brand new copper pipes, which run the rest of the house. So I had to get rid of the calcium tank and move to a sodium hydroxide injection system. And just the anatomy of the system here, there's a 50-gallon slurry tank, which goes to a ground FOSS digital injection pump, which is a metered pump. And then the way the circuit works is the water comes in from the well here. It has a takeoff right here, which goes outside before any filtration. I use that for watering the yard, etc. It comes down, goes through a check valve, which I added, and I'll describe why in a second. And then it goes through a primary sediment filter. It goes into the water softener, where I added a mixing valve in the water softener to allow for a reduction of the hardness reduction, so the water's not so slimy. And then it comes down here. This is the injection port for the sodium hydroxide. Then it goes from here into a mixing tank, which is simply an empty tank to allow the sodium hydroxide to mix and maintain more of a steady pH. It comes out of the mixing tank, goes down a loop, and then comes through this flow meter. And the flow meter has a little optical sensor on it, and that little sensor is watching the little wheel that moves when there's any water flow. And that is what triggers the pump. So it's a metered pump, so the faster it moves, the more sodium hydroxide is dumped in, and it's supposed to maintain a relatively steady pH. The rest of the circuit then goes up to a water cop, which is a fantastic device. There are sensors all over the house next to things like dishwashers and washing machines and bathrooms. So if there's any leak and water on the floor, it not only alarms, but it actually turns off the water main, or at least the water right here. It goes through a secondary 1 micron filtration filter, and then it goes through a UV treatment and then out to the house. So ran into an issue with the meter where in the spring when I opened my pool and I was filling my pool, I was filling it with this line right here, which is unfiltered, and it was creating negative pressure and pulling water from within this circuit, within the house circuit. And it wasn't pulling a lot, but it was enough to make this little meter wheel jiggle around a little bit, and that turned the pump on. So I came home from work after filling my pool for half a day and burned the shit out of myself with sodium hydroxide, because it kept dumping a bolus of sodium hydroxide into the pipe even though there was no water flowing. And when I turned on the water and ran it, it was way too concentrated, which is a huge problem. And so subsequently to fix this, I just added a check valve in the system here, which prevents any backflow of water in the house circuit. And then I did test and make sure that when I'm running full-blown water out of that unfiltered line, it does stop it. So what I'm going to do now is I'm going to prep the sodium hydroxide to fill this tank, and you can do it one of a couple ways. The vendor that provided this tank provides 50% slurry solutions by the gallon, which are about $50 a gallon, and I would need, where I'm at now, at about 25% of the tank, at 12.5 gallons, I would need 6 gallons or $300 worth of sodium hydroxide to fill this. And so what I'm doing is I'm just mixing up and pumping in some granular sodium hydroxide, and so I'll just show you what is involved in that. It's a bit of pain in the butt, but it's significantly cheaper, and it will actually result in a more uniformly diluted solution. So you're not having big, huge dumps of concentrated stuff and then followed by water in the tank, and relying on osmosis for that to equalize. So I'll set up and go through the process. This is some of the safety equipment I'm using. To be clear, this video is not intended to be an instructional video, and I have no professional training in mixing this. This is just what I'm doing. So please take that into account if you're going to decide to do anything. Whenever I'm handling sodium hydroxide, I do try to handle it safely. It's pretty nasty stuff. It's very nasty stuff and will cause caustic burns almost instantly. So I use a combination of rubber gloves. I got a actual giant rubber apron that's used for chemistry. I also use a respirator mask for any minuscule particulate or aerosolized powder, and then I use glasses. And if I'm using any preparation that is more powderized than granular, then I wear a full face mask respirator to cover both my eyes and mouth with the appropriate filters. I also don't mix any of it inside my house in a confined space. I do it all outside where there's good ventilation. This is the sodium hydroxide that I get. I just bought it off of Amazon. Whatever you do get, you probably want to make sure that it meets the food chemical codex specification, since you're going to be using it and presumably in drinking water, household water. And then this is the mixing setup that I have. This is a cheap pneumatic pump that's designed for paint with stainless steel fittings on it that I got from Amazon. You could use a paddle if you wanted to. I got these 8-gallon stainless steel milk jugs for two reasons. One, when you mix sodium hydroxide and water, it creates an exothermic reaction, which is going to generate a lot of heat, and I didn't want to risk melting a plastic mixing bucket, which are not designed for significant heat, and it gets definitely hot to touch. And the other reason is this has a waterproof seal on the top, so when I'm transporting it from outside my house to inside my house where I'm going to pump it in, I can seal the top and not risk sloshing the very concentrated slurry all over me. When measuring the sodium hydroxide, I got some 64-ounce half-gallon containers. The solution provided by the vendor was a 50% solution in a gallon. So a gallon's 128 ounces. These are 64-ounce containers, so I'm doing 50% by volume, and it seems to work out just fine. Also, when I'm mixing it, I'm using stainless steel implements only. Stay away from aluminum because it will dissolve. So I start off with just putting water in the stainless steel milk jug. It's an 8-gallon jug, and I'm diluting the sodium hydroxide with 5 gallons of water. And this way, if I add all the water ahead of time, you're supposed to add the sodium hydroxide to water, not water to sodium hydroxide. So if I start with 5 gallons of water, then I don't have to add any subsequent water, and therefore I don't have to deal with any splashing. And when I mix it in, I just turn it on a very low speed to agitate it, and then slowly pour it in. All right, once the sodium hydroxide is mixed, I have a diaphragm pump that is safe for caustic solutions. And so I have basically a tube that is a check valve and then a filter screen to make sure I'm not sucking up particulate. And then that goes up to this little diaphragm pump. And then that just comes across and dumps directly into the tank. So this just becomes a process of add the sodium hydroxide, mix it so it's uniform, pump it into the tank, repeat, and do it 6 times. And I have 2 milk jugs, so right now while I'm pumping this one, the other tank is outside mixing. So that is 6 50% gallons, or the equivalent of 24 pounds of sodium hydroxide. That is pumped in, and then I'm just using water to flush the pump and make up the difference in the tank to a full 50 gallons. So this is basically my water untreated right now with a pH of 6.5 with some residual sodium hydroxide in my lines. And now I'm flushing the system out and recalibrating the pump to try and achieve a pH of 7.2 to 7.4. So I definitely overshot based on the current settings. The concentration must be a little bit higher, so I have to go back and dial back the pump a little bit, let it run, and just continue to titrate it. Alright, so this is where I'm at right now, which is somewhere between 7.4 and 7.6, which is actually okay. So I'll keep watching it and just make sure it doesn't keep climbing up, but should be pretty good to go.